Hello, everyone, and thank you for attending my talk. I am really pleased to be here, a little bit scared, but hopefully it will go away pretty quickly. So today I'm going to talk about some of our project that we started last year. And this is a new project for us. We call it Infernos, and this is basically our attempt to solve some of those problems that we've been hearing since this morning several times. So build a kind of usable real-time system for using various types of AI models to do useful stuff. So a little bit about me, like usual stuff. Born and raised in Ukraine, master's in physics and radio physics, Kyiv State University. I live in Vancouver, Canada since about 2005. I also founded my own company in 2006 and been pretty busy since we basically build, sell, and support systems for various operators of phone services, essentially. And also father of three, so which is pretty cool. So this is my second time in JAMUSCon, and since that my first time, I moved to a different area within Vancouver, and it's Burnaby, the city called Burnaby, and I went to the school district to put some of my kids to the school, and I found that surprisingly very similar logo. But to me, it's just fun. I mean, but it looks like very like me with a backpack coming here. So here I am. Anyway, a little bit more credentials about. I love open source. I've been pretty active in the past 20 years. Participated in a number of projects. I started with FreeBSD, which I discovered in my late years in the university. So I basically started, usual stuff, submitting patches, small fixes, documentation, this and that. Eventually, I got accepted as developer. Got a commit bit, still doing some work. And then I started my professional career, and my first job was to implement kind of soft switch. SIP was just a new protocol, like I think 1 year or 2 years out of ETF. So we found SIP Express router, which was very early project at that time. There was like only, I think, 5 modules, and there was no NAT support, no media support. So we started with adding those bits and pieces. So we started adding NAT helper module, contributed it back, created RTP proxy, created module for that. Again, contributed it back. Eventually, we, around 2005, created our own B2BA, which is also open source. And we used it as a kind of backbone for our products and use it ever since. Well, there are a lot of other patches that I worked on over the years for various projects and stuff. So, yeah, this is how my kind of my early days in machine learning. I discovered stable diffusion, tried to run it locally, and to poke some fun at my friends. This is Lorenzo, kind of in the future, in a few years after he, gets his running. Very good. But seriously, on the machine learning team, my real path in machine learning started probably around 2010, I read the book, which I highly recommend it if you never heard of it. It's called Scientist Engineer's Guide to Digital Signal Processing. It's a free book, you can download it. It's pretty old book, like surprisingly, like I think 90 something or even 80 something originally, but it had a pretty decent section on neural networks and just basic principles of, like how it all works. That caught my interest, but I tried to play with it for some projects, but there was no really, like, nothing. So you had to really program those neurons by hand. So yeah, it did not go anywhere. Then at around 2020, I discovered Comma AI. Those guys are really great. They build AI-powered vision-based fully, like just vision device that you can install in your car. And it could be any car. Pretty much all cars built in the past 10 years have all the hardware necessary for it to work. And this is just a small device that you plug on your shield and it runs models and stuff like that. So it was quite an eye-opener for me that this stuff really works. Then I played a little bit with trying to train my own toy model to detect DTMF out of raw G729 frames, because G729 is pretty much a bunch of coefficients that are, jammed into frame. So technically speaking, you can probably detect DTMF without decoding the audio, which is kind of interesting because then imagine you have 1,000 streams going, and if you can get pins or credit cards out of it, stuff, it's kind of scary but also interesting. Then around last year, I played a little bit with Deep Face Lab. This is just a clone of face swapping AI that you can just deploy and play with it. So I made some fun videos for GlueCon last year. Then I also went to participate in ComaHack. Same guys, Comat organized this Impairment 23. They basically put the same device they put on the car on a little rolling kind of platform, and we've been trying to program it, train it so it can navigate the office just by vision-based within like 48 hours. We did pretty good progress. We did not win, but it was nice. Anyway, I also run, since my early days, I liked Game Digger. This is like old 8086 type game that I really liked in my early days, and I always wanted to add AI kind of, automatic playing stuff. So I tried to port Miseru, which is a project that uses reinforced learning to train AI to play various simple pixel-based games. I did not finish it fully, but it did got quite a good progress on that. And we'll see it helped me a little bit in other stuff. Anyway, for this particular work, some of the motivation we already heard about. Why do we think it's important? First is, it's always interesting to explore the new space. We also is in my professional life and in our company, we spend, I don't know, probably like easily 1 or 2 man years building old style, text to speech kind of system where you have just a bunch of prompts and you glue them together. So you record like 1, 2, 3, and then all this stuff. We built pretty useful system. It supported like 8 or 9 languages for customers doing like calling cards, top up, and stuff. So definitely, like when we've seen models coming up that can do that stuff. That was pretty cool. In my own opinion, I think there are many reasons why people might want to run this stuff locally. Some of them we already heard over the past day or two. There is like privacy, there is latency, there is all this sovereignty and all this stuff. So I would say in a few years from now, we probably see most of the AI voice generation be done locally, not by a third-party company, but just your own stuff. And if you look at the projects like Jitsi or Janus, you see those stuff gets integrated. So I think this trend will continue. Anyway, some of the challenges that we knew are there. So machine learning is pretty much all Python. There are some exceptions, but generally that's the rule. And something that is pretty easy to overcome. I don't know about that because Python is have a few challenges. Obviously, everybody knows about GIL, about lack of real trading and stuff like that. So essentially, we're basically trying to marry usually like a bunch of C code to Python. So you build some glue interfaces with whatever FFmpeg or anything else. And it kind of, in my opinion at least, looks a little bit ugly. So we came from a little bit different perspective. We tried to see what if we bring real time to Python. So instead of trying to use something like free switch, try to build some scripts or web APIs or whatever. We try to see what we need to bring to Python to make it a useful real-time system. Anyway, so at the time, as I said, we already have pretty good SIP stack, which is Python-based, so it kind of naturally fits into the Python. So we started pretty easy. So took SpeechT5 by Microsoft, which is open source pretty much, and it's pretty okay model. It's not the latest, but good thing about it is it's free. Plus, there are a lot of people who train those models right now. So if you look at Hugging Face, you can find a bunch of different languages trained by people, and it's not a huge model. I think it's 150 million models, which is by today's standards is pretty small. Anyway, so we started with pretty small proof of concept, and the idea was that everything runs in the single process. We have call coming in, we spin working thread, and then it does inference and RTP generation and kind of plays some prompts. Well, I mean, it worked for one session, it worked for 2 sessions. But then we tried the 3rd session and yeah, we ran out of resources. So basically, all 3 sessions started to be choppy, obviously. And so basically, we started kind of thinking what's the problem. So the first thing what I thought was maybe it's hardware. So we started with this very small GPU on the left, which is NVIDIA 1050i mobile version, which is like 7 years or maybe 10 years old GPU. And I replaced it with RK770, which is like last year GPU, and it has arguably like 10 times more compute resource. So we expected, okay, maybe this will bring us from 2 sessions to maybe 20, which is kind of becomes useful because, as I said, we're in wholesale, most of our customers. So something that can only support, 1 to 3 sessions is not particularly interesting for us, at least. I mean, yeah, so we tried that and we failed. So it's still, even with the bigger card, we can only get like 2 sessions, essentially. We tried other stuff. We tried quantizations. But then again, quantization does not get you very far. If you look at any like GPU characteristics, you usually see that in terms of operations per second, you might even get smaller performance for int8, for example. And it's just the way those GPUs are built. What it does, although it does reduce GPU memory usage. But as I said, for text-to-speech in particular, that was not a huge concern because speech-to-5 that we use is only 150 million parameters. So you can probably fit, I don't know, 20 instances of those in any modern GPU. So yeah, basically we get back to this kind of try to see what we're doing wrong here, and what I kind of discovered that there are better ways to do it. So we're not really doing this optimally because you don't really need like 3 copies of the same model. And the problem with GPUs, even though they have like 1,000, maybe even few thousand of execution cores, usually it's like single task. So if you run 2 models, you basically just time slicing. So your models are not running really in parallel. So it's only one of them is running at the time. So at some point, you're just hitting the limit and it becomes not real time. Another problem that you're not utilizing GPU in this way because, as I said, those GPUs have pretty wide kind of execution. So there's a lot of execution resources. But with something like speech-to-5, you're not loading all of them. In one session, you're just loading portion of GPU. The rest is just staying idle, pretty much, wasting, time and money. So yeah, as I said, some of the stuff that I played with, we came to conclusions that we can use batching to actually improve the situation. And it kind of worked surprisingly well. I mean, instead of running 2 sessions in at top in my A7070, 770, we can now 3 times real time can generate 50 sessions at the same time. The only trick is that you need to batch them up. So you cannot kind of insert in the middle. You need to batch it up, generate all streams, and then put the another batch in, then generate the next, and next, and next. So the latency is a little bit of concern, but since the model is small and on a more powerful GPU, you should be able to run, 2-3 instances and reduce latency that way. So you basically, while one batch is running, you can start another one in parallel and still have real-time behavior. So having figured that, I started looking at how we can scale it up further. So obviously, text-to-speech is not enough. We also want speech-to-text. We want LLM. So how we scale it up? Like, are we using some processes? Do we write some glue framework? And yeah, that game that I mentioned actually came handy. As part of that Mu0 package, I discovered Ray, which is pretty powerful framework. They developed it in Berkeley. I think it's pretty stable version 2.9. I think very popular, very easy to use, really great. And it's obviously native to the whole machine learning landscape, and it allows you to do pretty cool stuff. So you can pretty much abstract away all the complexities of your hardware configuration, cluster configuration, and basically the same code runs either locally on the same machine. You can start those actors, as they call them, in Ray, or you can start them on a cluster of machines. From programmability, it's the same. It also has pretty cool features, which is kind of related to Python. You can, instead of just doing remote procedure call, you can pass Python objects around. So you basically can pass, instead of just a callback to like RTP actor, you can pass the whole object that will do some kind of extra processing without modifying the code of the actor itself. So it's kind of very nice. I have not seen this in any other stuff. It's also pretty full featured, so you got a lot of tools. There is like dashboard, there is a debug interface to get like usage, get some stacks and stuff. So basically, we started with that and laid out a few actors to handle like SIP, RTP part, inference part. Another thing that you can obviously have a lot of those actors doing the same thing. So if you need to scale it up, you just have, instead of one inference actor, 5, for example, or whatever. The code is pretty much the same. Yeah, this is just my local setup. So I have 3 big nodes. Those are with the 87070 GPUs. I also got a few of those small ones. They have one of those small GPUs. Not very powerful, but it allows me to have both Intel and NVIDIA hardware, plus testing on low power hardware helps to identify any issues, performance issues and stuff. Oh yeah, we already heard a lot of Silverwatt. We use that as well. One thing that I did not mention is that unfortunately, batching mode is not supported by all of the models. Some of them, like Whisper, do support it very well, so it comes out of the box. Some of the other, like Silverwatt, for example, they technically support it, but the Python API is not built for that for some reason. I try to speak to those guys, to the afters, and they like, I mean, we think we like simplicity. You know, nobody going to use it, which is kind of, to me, strange, because you're just wasting GPU resources, because that Silverwatt can process like 200 streams pretty much in real time if you batch them up. Whether or not you will be able to do this if you load 200 versions of that model, I have not tried, but I really doubt. But anyway, this is how our RTP agent looks at the high level. So we have threads for each session, and then we have one Watt thread for the agent, and then we get RTP, we decode it, and ship it to the WAD thread, which does the stuff that the previous speaker have alluded to. So it basically splits audio into chunks, and then we use Ray remote call interface to send those chunks to the speech to text. And I have not really drawn it. We also get callbacks from the text to speech to actually mix in generated audio into real calls, so we can do live translation. So basically capture the audio, send it for inference to Whisper. Then from Whisper we translate it if needed, because Whisper can also do auto translate, so we can use that. Or if needed, we can translate it to, I don't know, Chinese, for example, I don't know. And then generate audio and mix it into real session. And then for the pass-through pass, we just send audio from what thread to particular thread locally. Yeah, so this is the first application that we are pretty close to finish up building. It works. We did a proof of concept, and basic idea is that we can do live translation for calls between two parties, and it works pretty well. Now, we also started looking at optimizing it. So basically, one thing that we did notice that we can reduce overhead quite significantly by letting the pass-through audio go through local queue instead of rare PC between one client thread and another. So basically, it reduces like 3 times overhead of those calls. And obviously those, we're doing very little chunks. So it's like for the pass-through, we're doing 0.1 second chunks. So there's like 10 chunks per second for each session in each direction. So it gets expensive pretty quickly. This stuff has already been mentioned. Just piping output from text to speech model to speech to text does not always work. We need to budget. So stuff like numbers, acronyms, already mentioned, various accented characters, and other stuff. We're still figuring it out. So there is a little bit of code still needed for that. So hopefully at some point we either see models that are trained on unified kind of dialect, or maybe another possibility is that you can take embeddings from something, output embeddings from something like Whisper, maybe Tray model to translate those embeddings into speech-to-5 embeddings and feed them directly instead of going through text. Another possibility. So we'll see. For now, we're just doing budgeting. Now on performance side, as I said, it's pretty good. We have 2.5 about real time with speech-to-5 for 50-75 sessions on A770. We did a little bit of modify speech-to-5 to get much lower first audio latency. So I had to rewrite some of the parts. It's all open source, so you guys, there will be links at the end. So if you guys want to look at it, it's welcome. We don't do any padding tricks, so it's 1.1 second is really like from text coming in to the text-to-speech inference to the first audio coming out. So it's pretty nice. For speech to text is not ideal, but still on this machine I can do about 7-second delay from chunk of audio up to 30-second coming in to text coming out. So it's usable, I would say, and hopefully it will improve after a year or two. So with all that, we think that something like 3060 should probably run, full text-to-speech translation, live translation combo for few languages for up to 20-50 sessions. And obviously, as I said, with our architecture, we can scale up with pretty much linearly with number of GPUs or number of cluster nodes. Some of the things that we want to have next. So there is obviously needs some kind of configuration file, which will probably start working this week. I also want to provide Docker container. I will also be doing hopefully live demo at OpenShift Summit in Valencia next month. So I brought 3 of those for that. We obviously want at some point have LLM integration. It's not terribly difficult to just try to focus on getting some usable functionality first. Other models, I've been looking through some of the more recent text-to-speech models. Hopefully, we'll see some of them providing better either audio quality or better performance than speech-to-5. We also want to probably look at overall media handling optimizations that we can do. There are some parts right now that are still kind of too high level. We will probably try to lower those into C modules and support some other media types. So video is obvious pretty much. We want to add some support for like segmentation models and all the good stuff. So essentially, we want to build more like a framework that you can then use to kind of put together your application. So here, for example, I drafted a little bit how kind of automatic translation service for kind of conference room might look like. So you have audio coming in from a speaker, and then you have a bunch of listeners who can connect. And here we have SIP, but it could be like anything WebRTC. Should not be terribly difficult. And from like application perspective, is pretty much the same. We have RTP in, and the rest is kind of similar. Well, I mean, yeah, try to look at the code if you're interested. It's all on GitHub. Give it a go. We hope to get it deployed into production next month. Right now, everything is like a little bit on the VIP branch, but it should change pretty quickly. Give us feedback, ideas, input, always welcome. And yeah, report any issues. Maybe somebody would get interested enough to add the WebRTC front end. Some documentation, always nice. Yeah, put some stars, spread the word. And yeah, some links, as I mentioned, the project, our B2BA and SIP stack. There is Discord. You can find me there if you have any questions or follow-up. Our G729, so right now I didn't mention it, we support 7.11 and also added 7.29 codec. Other codecs can be added pretty easily. This framework is all there. There's a little library that I put together to do low-level RTP scenes, I call it. It implements jitter buffer and kind of RTP generation. So it takes care of like bit manipulation stuff that you probably don't want to do in Python for performance reasons, and just it's ugly. There is our modifications of Microsoft Speech T5. You can find it on Hugging Face. There are some more explanation of how it works. Yeah, pick it out if you're curious. And some of my social media handles. Yeah, that's more or less it. Thank you very much.